Welcome back everyone and welcome to another tutorial. So today we're going to be working on audio. Now before I get into what's going on in this episode, there was somebody that was having issues with their shader. It was not, for some reason, I guess their computer won't let them take a vector 4 and subtract a vector 2. So inside of the default game shader, it was world position minus cam pos. So what I'm doing is I'm just subtracting and then creating a new vector for cam pos 0, 0. That's the only thing I changed right there, and hopefully that'll fix their issue. So now with audio isn't really talked about much in lightweight Java game library, and it's not really, well, at least version 3. And there's not much examples or anything out there. I mean, there's some documentation, but not a whole lot. And whenever I said last week that I was going to do audio in this episode, my plan was to use WAV files, because that's what my audio is WAV files. So I was going to do WAV, MP3, OGG, just several different audio types, and found out that Lightweight Java Game Library 3 removed the WAV data. So I'm like, okay, I'll just grab the WAV data from version 2 and then bring it into version 3, which seems like it would be fine, but they have blocked off the ability to actually use it. So I figured I would just use Java's built-in audio. But the problem with Java's built-in audio is that there isn't individual sources, I guess you would say. Because since you play audio directly from the clip, you cannot play the same clip during the same time period. So if I have one listener or one source and then another source that has the exact same sound, let's say footsteps of people running around, you can only play that one footstep once at a time. So you would play it, and as soon as somebody else would step, say a split second afterwards, you would have to stop the audio, and then it plays it again, which is really ugly. But you can get around that by having multiple audio files. But why would you do that if it's the same audio clip? And another issue with it is that there's a lot of popping and weird noises with Java's built-in system. It's perfectly fine whenever you're playing like music or something like that, but in game-related state, then it becomes an issue. And there's ways around that, but you have to build an entire system around it, and I'm just not going to do that. So I kind of read the STB documentation, and I came up with this code right here. This code right here works perfectly fine. So stack push the memory stack, allocate the channel buffer, do a stack push, allocate the sample rate buffer, get a short buffer, which is decoding the file name. So it basically just takes the OGG file and it turns it into a short buffer. Or it turns it into like a Vorbis format short buffer. And then you get a pointer for the channels, pointer for the sample rate, pop, and then check the format, checking to see whether it's mono 16 or stereo 16. Then we just set AL buffer data, and then, well, here I'm just returning out, but you don't have to. And as you can tell, I have it commented out, and the reason why I have it commented out is because apparently STB Vorbis does not have the ability to pass in something that is attached inside of the jar. So we can't pass in a byte buffer. We can pass in a byte buffer, but only if it's a character byte buffer. They don't have a way to pass in a byte buffer that holds the information to a file, which is really ignorant why they would do that. Because, well, if it's in here, obviously it's going to be in a jar at some point. So why in the world would they not add that? So I completely scrapped that. So I had to do what I didn't want to do. And that was add somebody else's code. But as you can tell, I went through multiple different things to get to this point. And there is just no documentation anywhere on how to do this. I scoured the internet for days trying to find this, and that's absolutely ridiculous that audio is talked that less about. And audio is a huge thing. Without audio, you have a boring game that, like, I don't know. Have you ever played Call of Duty with the volume all the way down to 0? Like, it doesn't work. It's just stupid. Audio is a huge part of every game. And I guess it gets taken advantage of. And you can see the same thing whenever you search for it on, like, YouTube or something. You're going to come up with the same issue. You're not going to find anybody that's actually talking about it. And if they are talking about it, 99.9% of the time they're talking about Lightweight Java Game Library 2, not 3. So I'm just going to cover this code. I know I've talked a lot about pretty much nonsense, but at the same time it gives you a little clarity as well that it's not talked about at all. So yeah, but this method works awesome. The guy that did it, there's a Lightweight Java Game Library book, I guess, and there was only like one source for this information at all anywhere, and like after like 3 or 4 days of research on it, and even for him, he skips over a lot of stuff. Like he doesn't show the whole script, basically, or what all it entails. It shows him doing like this right here for audio clip, or not really audio clip, he calls it like audio buffer or something like that. But then the rest you have to go find. So I had to go through multiple scripts of his and actually pull this information to even be able to create or import an audio clip. So I've done all this for you. So now it imports any audio clip, whether it's over here. As you can tell, my project, I put an audio folder in there temporarily. Here in a minute we'll automatically add that. And then over here in the resources, I also added it. So it doesn't matter if it's in the jar or if it's in a folder or whatever, it imports it. And I love the way that they do it. And we're probably going to add that same way of doing it for the rest of the files, either this time or some other time, because I really like the way that they do that. Right now we're adding a slash, and if it has a slash, then we're removing the slash and then importing accordingly. So we'll eventually change that and add this method because I really like it. All right, so let's get into this. Oh, and in the book he doesn't talk about imports, so I had to actually find the imports for it as well, which was ridiculous. I don't know why you would not put the imports. It just says put imports here. Okay, that tells me a lot. But here's the imports, unless if you have issues. And then right here I'm importing all of it. And then just those. Those right there. So I'm creating a new class. I put it in a new package called audio. Now I had to capitalize this. Actually, you know what? Let's refactor this. I am going to change this. Save that. I'm going to change this to sound. Hopefully we don't have any issues with that. Because you cannot use a lowercase audio. It does not like that at all. So create a new package called sound, and then create a new class called audio clip and audio source. So for us, if you came to this video and you were not following along with the tutorial, that's completely okay. Because, well, this is universal the way that I'm doing this. You'll just not add things like this. Of course, you won't extend engine.object because you don't have engine.object. We're only doing this for like drag and dropping inside of our engine. So the public class audio clip extends engine.object. We want to create a final ID of where we're storing our buffer. We need a private byte buffer Vorbis, and a private short buffer PCM. These are just the buffers used to store and get the information of the audio clip. Now, create a private static list audio clip clips that is just going to be a new array list of audio clips. That way we can store them, find them, and then after everything's over, we can actually delete those clips after everything is closed. And then private static and I, just so that we have an iterator. So for the constructor, we're going to pass in a file name. That way we can import it. And we're going to set ID to equal AL gen buffers because we're using AL, which is a lot like GL. So the kind of the way things are done is going to be a lot similar to OpenGL. So what we're going to do is we're going to try to cache an STB Vorbis information, and it's going to be malloc. So then we're going to create the PCM, and it's going to be equal to null. Because, well, if you store it outside of a try catch, you have to set it. So we're going to try to read the Vorbis n. So if you want, just create a read Vorbis function and just put a string, integer, and a STB Vorbis information. That way you can get rid of that error or not and just wait. And then of course it's going to catch an exception E. So if the PCM does not, or if the PCM equals null, that means that the information was not read in properly. So for me, I'm just printing a system error, and I'm going to pass in the file name and say just could not be imported, and then just return out of it. And then here we call AL buffer data just like we do GL buffer data. We're going to pass in the ID of the generated buffer. And then we're going to say info.channels equals 1, AL format mono 16, AL format stereo 16. So this basically just it checks the info channels and determines whether it's mono 16 or a stereo 16, and then sets it accordingly. And then we're going to pass in the PCM, and we're going to pass in the sample rate. And then after that, we're just going to add the clips to our list. And here we need a public final int get ID, just so that we can return a final ID so that we can do whatever it is we need to do in our audio source. Now we have a destroy method as well, kind of like just a delete method. So you delete the current buffer of this audio clip. The reason why I called it destroy is in case, let's say, we have the engine open and then we delete an audio. Later we're going to add more to this that is also going to remove it from the array and re-import it, and there's several different things we're going to do with that. So that's why I named it destroy instead of cleanup or delete or whatever. And then we need a static void cleanup. That way we can just call audioclip.cleanup, and it will clean up all the audio clips after everything is closed. So what we're doing is we're just looping through all the clips and then calling destroy, this method right here, on the actual clip. All right, now this method. He had several different methods, and I kind of condensed them a little bit. Not much, but you know, I like the way that I format everything because it makes everything look clear, and kind of condense some of the methods, but it's whatever, that doesn't really affect you any. So read Vorbis, we have resource, the buffer size, so the size of the buffer that we're using, and STB Vorbis information. So the info is basically just to like get the channels and stuff like that. So we're going to say Vorbis equals IO resource 2 byte buffer. And then we're going to pass in the resource and then the buffer size. So IO resource to buffer size or buffer byte or good lord byte buffer is this method right here, and this is one that I condensed as well. They had a resize buffer down here as well, but I completely removed that and then condensed it into this right here. All right, so in here it's going to throw an IO exception. So we need to cache a buffer. Then we're going to get an actual path. So it's going to be path.getResource. If files.isReadable path, and this is what I was talking about, how I really like the way that they did this, because for some reason I never really thought of doing it this way. And that is this right here. So if the path is readable, we're going to try a seekable byte channel, which is files.newByteChannelPath. And then we're going to create a byte buffer of fc.size +1. So it's going to be the files byte channel size, and then we're just going to add 1 to it. And then while fc.read buffer does not equal -1, so while we're still reading, if you're not familiar with coding, this just basically means just continue until it's completely done. So this right here is for one file type, and then these are for the other file types. So one is for folders, one is for inside of the one is for folders, one is for inside of the jar, or inside of the a resource folder. So else we are going to, this big O line right here, going to create an input stream that is going to be equal to audioclip.class.getResource as stream resource, which is like how we import everything that is inside of a resource folder or a jar. And read byte channel or readable byte channel is going to be equal to channels.newChannelSource, and it's just going to be open. And then here we're going to create a byte buffer of buffer size, and then while it's true, we're going to read the readable byte channel in, or read the buffer into the readable byte channel. If bytes equals -1, then we're going to break. Else if, or if buffer.remaining equals 0, then we're going to flip the buffer. And then we're going to say buffer equals bufferutils.create byte buffer buffer.capacity times 2.put buffer. And that is the actual compression of an entire function they had down here, which was ridiculous. I just condensed it down to 1 line instead of it taking up an additional like 10. And then all the way at the end here, we're going to flip the buffer and then return the buffer. All right, so back up here. Here's our error, so it's going to be stack.malloc_int1. It's going to be an int buffer. We need a long decoder, which is going to be equal to stb vorbis open memory. And then we're going to pass in the vorbis, and then an error, and then pass in null. So we're going to say if decoder equals 0, then we had an issue opening this memory. So it's going to throw a new runtime exception, and then pass in the error information. And then we're going to say stb vorbis get info, pass in the decoder and the info. Going to get the channels from info, and then set the PCM to equal memoryutil.mem_alloc, whatever, short, stb vorbis stream length and samples, and then pass in decoder, and then limit the PCM to stb vorbis get samples short interleaved, and make sure it's interleaved, and pass in decoder, channels, PCM, and then times channels, and then close the decoder from stb vorbis, and then return the PCM. Now, like I said, none of this I wrote. Well, I manipulated it, but this is this other guy's code, and I wish I had the website pulled up just so that I could at least say, hey, this is where I got it from. But besides, you know, the edits that I've done, a lot of it was his. You know, I added this, of course, all the easy stuff. So that is it for audio clip. Now we need audio source. So now that we can import an audio clip from, you know, jar, resource folder, or our project folder, now we need our audio source. Now that's the only thing that I use from somebody else's code, because, well, I hate doing that. Okay, so with audio source, now once again, if you're here just to learn about audio and lightweight Java game library theory, then you are not going to extend logic behavior. This is only for people that are doing the engine. So the first thing that we're going to have, oh, here, let me show the imports, just because I don't want to be a douche. Basically just importing all of AL10. And then we need, of course, list, array list, and we're importing logic behavior. So first variable we need is the audio clip that is currently attached to this audio source. Public float start gain equals -30. Now this is gain, not volume. Some people get this mixed up. Gain is not volume. They have similarities, but they're not the same thing. And I have it set currently right now to dB, so we're looking at the decibel. We're not looking at the looking at volume, which is like 0 to 1 or 0 to 100. We'll add that later, but not right now. But later we'll add more stuff into the source, like switching it from dB to volume. Or it's still going to be gain, but it'll be set like volume. So we need a private final int ID, of course, because we need to generate the sources. And then just like we did with audio clips, we're going to get an array just so that at the very end, when the application closes, we can, of course, go through them, delete them. And here's the constructor, so public audio source. We're going to generate sources to get the ID. So AL sources. And then immediately after, we're going to set the start gain. So we're going to set gain and then set it to whatever we have it started at. And then sources.add this. So we're just going to add it to the list of sources. Here as well, we are going to be setting the gain to start gain. So as soon as we hit play, now start gain is the time that you hit play or the time that the script is loaded. That's it. If you set start gain after it's playing, say you're trying to move it up and down or whatever, doing something crazy, it's not going to work because it's only for starting, not pure gain. We have a function to set the actual gain. So we're going to set gain, start gain, and then we're going to call AL source play ID. We have looping, which we will add later. We're not going to do it right now because, well, it's not really that important at this moment in time. We have other more pressing things to do first. To do rather than doing all this extra stuff. We just want to get audio playing and doing what we need it to do. And then here we're going to set the clip. So set clip audio clip C, and it's going to be clip equals C, and then we're going to say AL source ID. It's going to be AL buffer, and then the clip's ID. So the ID of the source, AL buffer, ID of the clip. Then here we're going to pause, so we're going to AL source pause the source ID. Stop, AL source stop source ID. And then here is our set gain method, which we call multiple times up here. And this, so if you're in play mode, it is currently playing. If you want to change the volume, call this function. Do not call start gain. And what it is, it's going to take in a float of what we want. And it's going to call AL source F, the ID for the source, and then we're going to be calling AL gain, and then pass in the value. And then here under the destroy method, just like how we did the audio clip, same reason for calling it that as well. First thing we need to do is we need to stop the source if it's currently playing. And then AL delete sources, the source ID. And then we're going to sources.remove this from the list. All right, and this is going to be public static void cleanup. So just like before, we're going to loop through them all, except for this time we're going to say sources.get0.destroy. So since we're removing it from the list, we need to get the first element in the list every loop, because we're deleting the first element in the loop every time. All right, and that is it. Now we have an audio source, and we have the ability to import audio clips. Now we have to actually create the sources for OpenAL. So right now I have it in here. I may hold on here. Application is minimized. Application.init. Okay, so for now we're going to have it in here. We're probably going to be putting it somewhere else. I just don't know whether I want to put it into application, like, because that's where we initialize our OpenGL code. So it would make sense to initialize our OpenAL as well. Or if I just want to put it into audio source, or I'm not really sure about that yet, but we will figure it out. So here we need to open the device. So we're going to call ALC10, and I'm using ALC10 just because I don't want to import the whole thing just for a couple calls. So ALC10.ALC open device, and then it's going to be byte buffer null. And then ALC capabilities, device caps, and we're going to call ALC.create capabilities device, just kind of like how OpenGL works as well. Need to create the capabilities, context, all that crap. So long context, ALC10.ALC create context. And we're going to pass in the device, and then this is going to be an int buffer, which is going to be null. And then call ALC10.ALC make context current. So we got to take the context, we got to make it current, and then we got to set the device capability, or create the device capabilities. So al.create capabilities device caps, and that's it for that. Here I am importing. So for those of you not following along with the full series, inside of my resources folder, which is a resources folder, it's not just a folder, it's a resources folder. I have audio. Yeah, I have an audio folder inside of the resources folder, and I've got audio in here. Now, inside of my project, I have my project and then an audio folder in here. So that's how it's set up. So this is my project folder. This is my resources folder, and that's how this series is set up as well. We're using project folders as well on top of our resources folder. So it could be either one. So that's how it could call this or this, is because this is the same path. So the path to the project, the only thing that is different is the path of where the audio folder is at. All right, and then here we're going to create the audio source. And then here I'm just setting the clip. And this is just for an example. I'm going to be deleting this because we're going to be automatically importing our audio, just like how we do all of our other assets. It's going to be all automatically imported. So the second that the application loads, it's going to load all the assets that we need. Then here, just for testing purposes, I'm just saying if input.keydown G, I'm going to say the audio source needs to stop. and then I'm going to play, which actually... I don't even know if I really even need to do that. I don't know. I'll see with both ways. Now, for those of you not following along, this is not going to be something that you can put in. Because, well, input is for the series, not just for audio. And the reason why I'm going over this for everybody who looks at the video is because, you know, audio is, like I said, something that is very rarely talked about for Lightweight Java Game Library 3. So I want to cover all my bases. And then at the very end, of course, after we close the window, going to audio.clip or audioclip.cleanup and then call audiosource.cleanup. And then after all of our cleanups, we're going to call alc10.alcCloseDevice. If you do not add this, then every time you're going to get an error saying that the device was not closed. So after that, and we run it, don't worry about this right here. It goes away for some... I think there's something going on with the project or Eclipse or something that's being stupid. It keeps on like throwing an error saying it can't find this image right here. Well, if you can't find it, then how did you put it on there, you dummy? And then why did the error go away? So I think it's just Eclipse being retarded. So if we run it, I have it set to G. I don't know if it's loud or not. Actually, let me... Oh yeah, I did. I set the gain at the very beginning. Okay. I don't want to like blow you guys' eardrums out. Alright, so I have it set to G, so I'm going to be playing an audio clip that I had for a 3D platformer game I made a while back. Alright, so here we go. And if I hit G again, it will stop and then play again. And then close it. No errors, no warnings, no nothing. Now, before, and I have several of these just to test out each one. Which, let me make sure. That these work too. I don't know. I don't think I added the ability to get it from the project yet. Oh, stupid. Okay, if you click on the asset, you have to click over here just to run it. Just warning, heads up, if you guys don't already know that. It happens to me all the time. Because I have this in the project folder, not the resources folder. So let's see here. Okay, we do not have it pulling up from the resources folder right now. The null pointer n. Okay, so we will have to add that as well into there. So if you're here to learn about audio, that is completely it. If you're here for the series, well, actually it's about time to close this off anyways. Dang, I was hoping there was going to be enough time, but I think I just blabbed my way through all that. So yeah, I think we're just going to leave it like that for now, and then we'll fix it in the next episode. So the next episode, we are going to kind of add some more things to our audio. We're not going to be adding things like 3D sound. There's no point in adding 3D sound to a 2D game. It's overkill, and it's more crap than we need to deal with. So we won't be doing anything like that, or like attenuation and stuff like that. There's no point. So we're not going to be doing any of the 3D stuff, and we're just going to leave it for 2D, like logarithmic audio. We'll also add it so that it automatically gets imported. We may make some changes to all the other assets to incorporate the way that this is read in. Yeah, to add like this stuff right here. Because, yeah, like I said, I really like that. Yeah, I guess it really doesn't matter what I move on to in the future. I mean, here really soon we're going to be hitting up collision detection and resolution. We're going to be hitting that up really quick. Because I know that's like the last major thing for the engine. Everything else is just little tinkering crap and like add more shaders and the rendering pipeline and stuff like that for post-processing effects, because we don't have post-processing effects yet, because we're not actually using the shaders that are attached to cameras. But we will eventually get to that. But I guess it really doesn't matter what order I go in or anything anymore, because the likeliness of somebody actually getting to this episode, like, you know, straight down the line is very little. Probably one out of 100, if that actually watches the series will actually make it this far. But you can always download all the files and stuff from my Patreon for $1. So you can just watch the videos or whatever, just to learn what's inside of the engine. But like I said, I guess it really doesn't matter. But next episode, we will be finishing all this audio stuff. So we know that it works. We know that it's good. All the rest of the code, I can just fly through it. I don't have to prep all this crap and just blab my way through it. All right, so I will see you then, I guess. Have a great week, guys.